Module 1, Lesson 8, Solve for Unknown Angles, Angles in a Triangle. We start with some vocabulary. The angles of a triangle. Every triangle ABC, we have triangle ABC here, determines 3 angles. And we notice that they are the angles created at the vertices. Angle BAC, there's vertex A, angle ABC, and angle ACB. So we have our 3 angles. These are the angles of triangle ABC. The interior of a triangle is if a point lies in the interior of a triangle, if it is in the interior of each of the angles. So that's just talking about the inside of the triangle because it's inside all of the angles. The exterior angle of a triangle, now this might be a new one for you. It says let angle ABC be an interior angle of triangle ABC. So we are looking at angle ABC right here. And it says let D be a point on line AB. So we are going to extend this segment and create a point D such that point B is between A and D. So you can see here point B is between A and D. Now, angle CBD, this angle right here, angle CBD, is the exterior angle of a triangle. Now that's a lot of words. We can make it a little more simple. An exterior angle of a triangle is formed by a side and an extension of an adjacent side, just like we did up above. In each of our triangles here, angle 1 is an exterior angle. So we see the side is extended and we have an exterior angle. The side is extended, we have an exterior angle. And on this one as well. You can extend any side to create an exterior angle. So we could even extend this side, and then this would be the exterior angle. Additionally, angles 2 and 3 are called remote interior angles. And those are going to become important to us later on. An old friend, an isosceles triangle, is a triangle with at least 2 congruent sides. The congruent sides of an isosceles triangle are called legs. So our legs are on this side. They are congruent. The third side is called the base. So the base is this side down here. The 2 congruent legs form the vertex angle. So this is our vertex angle here. We'll color that one green, is our vertex angle. And the other 2 angles are called base angles. Now that should make sense. We will color those in blue. That should make sense because they're attached to the base of the triangle. This brings us to our definitions, postulates, and theorems. And here is a very useful theorem, and it is my all-time favorite. It's the triangle angle sum theorem. And guess what we're going to do? We are going to sum the angles of a triangle. The sum of the measures of the angles of a triangle is 180. So what we get here is the measure of angle B plus the measure of angle C plus equals 180. If you know the measures of 2 of the angles, you can use the triangle angle sum to find the measure of the third angle. So this is very useful to us. And here is our triangle exterior angle theorem. And this is what we were looking at before. The measure of each exterior angle of a triangle equals the sum of the measures of the two remote interior angles. So we extend our side, we create an exterior angle, angle 1, and the angles that are not near it, the remote means far away. The angles that are far away from it here are its remote interior angles. The measure of our exterior angle is the sum of measure angle 2 and measure angle 3, the remote interior angles. This is our exterior angle, and these are the remote interior angles. So that is very useful. You can find the measure of the exterior angle if you know its two remote interior angles. Also, look here. That's a linear pair. You can also use a linear pair to find your exterior angle if you know the adjacent angle instead of the remote interior angles. Now we are going to talk about isosceles triangles. And we have the isosceles triangle theorem. And it says if, our requirement, if two sides of a triangle are congruent, meaning we have an isosceles triangle, we're told our segments are congruent or they are marked congruent. What is our result? Then the angles opposite those sides are congruent. These angles right here. So if we have an isosceles triangle, the base angles, these are our base angles, are congruent. Now you probably knew this about isosceles triangles, but now we have a theorem that we can use that shows it. We also have a converse of our isosceles triangle theorem, and you remember what converse means. We are switching our if-then. So if two angles of our triangle are congruent, so we have our two angles here are congruent, then the sides opposite those angles are congruent. So if we have these two congruent angles, then we can mark these sides congruent and we have an isosceles triangle. So two very simple but very useful theorems there. Now, an isosceles triangle is special. Isosceles triangles have symmetry about a line that goes through the vertex angle. This says if a line bisects, two congruent every time we see that word, bisects the vertex angle of an isosceles triangle. So if we have an isosceles triangle, and we know that because we have the congruent sides, and then we have this vertex angle is bisected by our line here. This line is the angle bisector of our vertex angle. Then what happens? Then that line is the perpendicular bisector of the base. So that is hugely special. So that line becomes perpendicular to the base and bisects the base. Very, very special triangles. Some new vocabulary for us here. A corollary, this is new, this is different from converse. A corollary is a theorem that can be proved easily using another theorem. Basically, it's like an extension or a special case of the other theorem. So our special case here is the corollary to the isosceles triangle theorem. Now, the isosceles triangle theorem says if we have an isosceles triangle, two congruent sides, then our base angles are congruent. This one says if our triangle is equilateral, that's three congruent sides. 1, 2, 3. Then what's going to happen? Your triangle is equiangular. This is three congruent angles. So we are able to mark 1, 2, 3 congruent angles there. Now this should not be a surprise. Let's look at this. If we have an isosceles triangle, let's say that our isosceles triangle is right there, then these two angles are congruent. But this is an equilateral triangle, so it's not only isosceles from that direction, it's also isosceles from this direction, which means these two angles are congruent. And it's also isosceles from this direction, which means these two angles are congruent. So this should really not be a surprising outcome. It's just a very special isosceles triangle. And finally, we have the corollary to the converse of the isosceles triangle theorem, which said if our two base angles are congruent, then our sides are congruent. We have an isosceles triangle. Well, I'm sure you've guessed it by now. If your triangle is equiangular, that's three congruent angles. So 1, 2, 3. Then guess what? The triangle is equilateral. 1, 2, 3 congruent sides. So no big surprises with the equilateral triangles. They are just very special isosceles triangles, which is why they get a corollary, a very special case of those theorems. Now, one thing pretty cool about equilateral triangles, each angle of an equilateral triangle has a measure of 60 degrees. And it's pretty easy to prove why that's true. So let's look at a triangle here, and we are going to say that it's equilateral. So we know that all of our angles are congruent. So we can say this angle measures x degrees. If they're congruent, we know that this angle measures x degrees and this angle measures x degrees because they all have the same measure because they are congruent. By definition of congruent, they have equal measures. And by triangle angle sum theorem, I know that x plus x plus x equals 180. So 3x is 180. I simply solve for x, and x equals 60 degrees. Pretty fancy. I know that we are going to very much enjoy working with triangles.